Hello, guys. Welcome back to MedZone African Motives. Still on our engineering science and two. This is mechanical drives. So we want to check how questions are given on mechanical drives and lifting machines from the question paper of November 2023. We have got first question 5.1. It was to state three disadvantages. Disadvantages of what? Of gear drives. I want us to be careful, the disadvantages of gear drives there. So we know of the advantages such as having a positive drive, the issue of the compact, this and that. But there, it was not about it. It was not about that. It was on the disadvantages. All right, the disadvantages that we have. What are the disadvantages of the gear drives? All right. So we know that as we are dealing with the gear drives, one, they are expensive in terms of what? The manufacturing. So we can say expensive to manufacture. So in order for us to have this, it's very, very expensive. So it's a disadvantage and also expensive to repair. So it's very expensive. So it is also expensive to repair. That's another disadvantage. And when it comes to lubrication, remember it requires a constant lubrication each and every time. All right. So it requires constant lubrication, requires constant lubrication. So it's a disadvantage on its own. And also you can talk about the driving and driven shaft must be close together, right? So it's another disadvantage that we have, that the driving and driven shaft, all right, must be close. So this one, it must be close together. All right, so these are some of the disadvantages that we can use according to our syllabus. We've got so many disadvantages that we can have or that we can opt for as long useful, but according to our syllabus, guys, that's what we have there. All right, then 5.2, we are given that a chain drive, this is now a chain drive. Yes, driving pulley with 45 teeth driven. All right, this and that. Let us just try to have a sketch. Remember, this is now a chain drive. It's no longer just a normal belt drive. All right. This is having something like this. All right. This is just a sketch, guys. I hope you will understand me. So this is our belt here. Then on this side, gonna have something of this nature. All right. So this being our driver, and this being our driven. All right. So I'm just gonna use one for the driver. I'm just gonna use one. Then I'm gonna denote everything for the driven with a 2. Everything for the driver with a 1. Meaning to say the number of teeth, the speed, everything. I'm just gonna use 1. All right. So there we are given the driving pulley with 45 teeth. This is the driver. All right. This is the driving. So it's got 45 teeth. So I'm just going to write T1. T1, it's 45. All right. Like I said, for the driver, I'm just going to use 1. All right. And the driven, all right, a driven pulley with 90 teeth. This is the driven side 2. So I'm just going to use 2 there. T2 is equal to 90. What else? Then we also have the rotational frequency of the driving pulley, 660 revs per minute of the driving, which is N1 on the driver. So that's our N1, which is 660 revs per minute. So here we do not have their speed. We do not have this side. Okay. That's what we have. And the first question was to calculate on 5.21, calculate the rotational frequency. Just like this part, the rotational frequency of the driving pulley, but this time we need of the driven pulley in what? Revs per second. this was in revs per minute. So it's either we are going to change the revs per minute that we have originally here, or we just calculate our N2 and we know that our answer is going to be in revs per minute and we convert that to revs per second. Simple like that. All right, so let us just take this as it is, 5.21. Remember from the combination of the speed and number of teeth follows that N1 T1 is equal to N2 T2. And what we need is N2. So it's gonna divide by T2 here, by T2. So that N2, which is the rotational speed, in this case, rotational speed is gonna be N1 T1 over T2 from this side. So it's just a substitution that you're making in this case, all right? You're just substituting your values that you're given, which is N1 in revs per minute. That's 660. Take note, it is in revs per minute. So it means our answer is going to be in revs per minute, right? Times T1, which is 45 over T2, that's 90 in this case. So that means we are going to obtain N2, which is the speed. Like I said, it is going to be in what? Revs per minute. Since this N1 was in revs per minute, so that's 330 revs per minute. But the question was, we are supposed to have this in revs per second. So how do we convert per second? Remember, a minute is equivalent to how many seconds? 60 seconds. So in place of the minute, we are going to write this as per second as 330 revs over the 1 minute per minute. Per means 1 per 1 minute. This 1 minute is equivalent to what? To 60 seconds. So it's going to give us revs per second, per each second now. So we're just going to divide, and that was going to be 5.5 revs per second. So that's our N2. I'm just going to write a small letter for the revs per second. That is how we could have calculated this speed. Just like that. Okay? Know your conversion also. Be careful, knowing that a minute is equivalent to 60 seconds. I think that we are used to by this time. All right, then 5.22 to calculate the velocity ratio of the chain drive. We need the velocity ratio according to what we are given. We've got the speed now. We have got the speed here. So we can use the formula with the speed. Remember, there's a formula for velocity ratio that consists of the speed. That's 5.22. That states that the velocity ratio is simply the speed of the driven over the speed of the driver. So we have got the speed of the driven. Since the driver is already in revs per minute, let us just use the revs per minute here. So we got our answer in revs per minute for N2. It was 330. So that was 330 over the N1 was 660. So this is going to give us 1/2. So it simply means 1:2. 1/2 is a fraction. Simply 1:2 as a ratio. All right, 1/2 is a ratio. So you can even leave it like that, or you can write it as 1:2. So this is your velocity ratio. Use the same units, revs per second with revs per second. All right, that's the idea when you are simplifying persons that consist of the same units. All right. Then here on 5.3, we've got a differential pulley block with an efficiency of 75%. So this is, remember that a pulley block is simply, that's a Weston, like this. It's a Weston, okay? A Weston pulley block like this. Okay, you're supposed to also know this. So there we are given that it has got an efficiency of 75%. So that's 5.3. We've got an efficiency of 75%. And here's a mechanical advantage of 20. So the mechanical advantage there is 20. And the larger pulley has got 30 slots, the number of slots. So some they use capital letter N, Some they use capital letter S for the number of slots on the larger pulley. So I'm just going to use capital letter S. You can use capital letter N. For the smaller pulley, you use small letter S. And that one, you do not know. That one we are not given. So the question was, calculate, all right? That's 5.31. Supposed to calculate 5.31. The load that can be lifted by an effort of 800 Newton. So we've got the effort in this case of 800 Newton. And we are supposed to obtain the load. From where? From this information, how can we calculate the load? Remember, from the mechanical advantage, we can use this formula because we know that the mechanical advantage is equal to the load over the effort. That's the load over the effort. And we have our mechanical advantage, which is 20 in this case. So 20 is equal to the load, which is the one that we are supposed to calculate in this case. So we're going to have the load over the effort. And our effort is given as what? As 800 Newton. So this is just going to cross multiply 1 times the load. So this is going to be, the load is equal to 200 times 800. So you're going to have 20 times 800. So this is 20 times 800. So that is going to be our load. So if you multiply 20 times 800, this was going to give us 16,000 Newton, which simply represents what? 16 kilonewton. So this is your load in this case, this part, okay, which is 16 kilonewton. That is the idea there, okay? So you just have to understand the questions, how they are given, and how to play around with the information that you are given also. Then 5.32, the displacement ratio of the pulley block. All right, so the displacement ratio is the same as the way we calculate our velocity ratio, all right? That's the same way. So instead, I'm just going to write VR so that you don't understand, but that's the displacement ratio the same way for velocity ratio, which is given as, this one is going to be 2S, which is the one that we have on the bigger, which is the larger pulley, over the difference that we have of these, which is S minus S, the difference in the number of slots, okay? The difference in the number of slots. But we do not have this one. So this formula is limited. Remember, we do not have S, right? So let's leave this one. Let's think of another formula which consists of the velocity ratio. There is this one again from the efficiency. Efficiency is equivalent to the mechanical advantage over the velocity ratio times 100%. So we can take advantage of this formula to calculate our velocity ratio, which is the displacement ratio. All right. Efficiency, we are given here 75%. If we divide by this 100, it's going to be 0.75. So 0.75 is equal to the mechanical advantage, which we are given here as 20 over the displacement ratio. So that is going to give us the displacement ratio. If we cross multiply, that's going to be 0.75 times VR is equal to 1 times 20 this side. That will be a 20 from your mathematics. You can cross multiply this, all right? So that is divide by 0.75, divide by 0.75. So this is going to give us our velocity ratio in this case, and that was going to be 26.66666 and so on and so on and so on. So just approximating to the nearest whole number, guys, it's just gonna have an approximation of 27, right? That's our velocity ratio. That's like 27:1. Okay, okay, that's it. So just an approximation, you can write 26.667. It's fine, but just write 27. It's just fine. They will mark you like that. As long as the first one you wrote all the decimals, then you approximate. It's fine. 5.33. The number of slots in the smaller pool, this is the one that they're asking now. So that's that you see that formula was not going to work because that one we are even asked to calculate it here. All right. So remember for the number of salts, I talked about that formula for the velocity ratio, the same that we calculated the displacement ratio. So you can now take advantage of that because I wrote this formula and said it is equal to 2s, 2 times the product, 2 times the number of slots on the larger pulley over the difference of this number of slots. So with this formula, this S is the one that you are supposed to calculate for the smaller pulley. This is for the larger pulley, capital letter S, and this capital letter S is for the larger pulley. So we have the velocity ratio, the one that we calculated here, which is 27. So I'm just going to write this as 27 is equal to 2S, which is 2 times the number of slots on the larger pulley, which is 30. So that's 2 times 30 over the larger one, the number of slots, which is 30, minus S, which is for the smaller one. Sorry for that. Okay, very, very sorry for that. So you need to calculate this one for the smaller pulley. Okay, so what can we do? We are now back to our mathematics. This is no longer science. We are now back to maths. So 27 is going to affect everything in this bracket. So that's 27 times the bracket of 30 minus S is equal to 1 times 2 times 30. So if you multiply 2 times 30 there, that's what? 60. So instead, we can just divide by this 27. Divide by 27 here, divide by 27. So we are going to be left with 30 minus S like this. 30 minus S is equal to 60 over 27. So instead of us working with decimals and rounding off, we're going to have a lot of rounded off values. Just transpose the 60 over 27 this side, transpose S that side, it becomes a positive. So 30, if we transpose this, it becomes a negative, that's negative 60 over 27 is equal to S this side, it becomes a positive. So we are simply going to evaluate this, which is going to give us, if we simplify properly, we are going to obtain 27,777. Why is it approximately this one, all right, which is equal to S? So therefore, S, the number of slots, going to approximate to the nearest whole number. So how many slots do we have? 7 is going to change this into 28. So approximately, this is an approximation. We've got 28 slots on the what? On the smaller pulley. In this case, we've got 28 slots like this. Okay, so this is what you are supposed to have as an approximation value or as an approximated value to the nearest whole number for the number of slots. Yeah, it can be like that. You must play around with your questions, understand your questions properly, all right? That is it, guys. You need to understand how the questions are given and how to answer the questions. Then 5.4, define the SI unit Pascal. Define, or you need to define. Remember, the Pascal is the SI unit. This is the unit of measurement of what? Of pressure, which is 1 Newton per what? Per square meter. So it's the unit of measurement of pressure, which is 1 Newton per square meter. Then name 3 factors for determining the pressure exerted by a vertical liquid column. If we are given a vertical liquid column, in this case, in considering a certain height, what is going to be the factors to determine that pressure? So remember, the pressure is equivalent to rho GH. So from these are the 3 factors when taken up on a vertical, considering the height, the vertical height. So what do we have for the density in this case? So the factors affecting, one is the density. So we have got the density, okay, of the liquid, which is the liquid that is taken, the density of the liquid. Okay, we also talk of the gravitational acceleration, which is G. So you talk about the gravitational acceleration. It affects gravitational acceleration from what? From gravity. gravitational acceleration. Sorry for that. Acceleration like that. This is simply from where? From the gravity, all right? Then the height, which is the height up, which is the height of the liquid column. So this is the height of the liquid column, up, going up, height of the liquid column. Okay, so these factors, they do affect your pressure. If one changes, except for the gravitational acceleration, just going to maintain that to 9.8. So the density is going to change depending with the liquid that you are working. Is it water? Is it oil? Whatever that you're working, it has got its own. This one is for the type of liquid that you're working with and the height taken up as you are going up. If you covered 5 meters, if you covered 2 meters, so this height of the column is supposed to be what? In meters. All right, remember that density is kilograms per what? Per cubic meter. And our gravitational acceleration, it's given as meters per square second, 9.8 meters per square second. So these are the units. So that's it, 3 marks for that. So guys, we just need to work with more questions, revise as much as you can, prepare yourself thoroughly for the exams that are ahead. If you're preparing yourself for N3, this is the right time to start revising as much as you can, gather the concept of the topics and how to answer those certain topics. You'll see that it's just a repetition throughout and throughout.